Finally, let us get to know molecules. When atoms of non-metals share electrons, they form an electrically neutral aggregate called a molecule. When the chemical symbol of a molecule is written out, you can distinguish it from an atom by the subscript following the element symbol, which indicates how many atoms are present. For example, O is the symbol for a single atom of oxygen. On the other hand, O2 is the symbol for a molecule of oxygen gas consisting of 2 oxygen atoms. O3 is the symbol for a molecule of ozone consisting of 3 oxygen atoms. Non-metallic elements exist in nature as diatomic molecules consisting of 2 atoms of the same element. They are more stable this way rather than as individual atoms. Diatomic molecules are H2N2, O2, F2, Cl2, Br2, and I2. Among these examples, bromine is liquid, iodine is solid, and the rest are gases at room temperature. Sulfur and phosphorus exist as solid polyatomic molecules of S8 and P4. Molecules could also be composed of atoms of different elements, whether diatomic or polyatomic. Examples of diatomic: HCl, HBr, H2S, H2O, CO2, and N2O. Examples of polyatomic are C10H8, C6, H12, O6, and C8, H10, N4, O2. Moving on, chemical formulas are shorthand symbols for compounds. They are made from the symbols of their elements in a pattern that shows the ratios of atoms present in the compound. Types of chemical formulas include molecular formula, empirical formula, and structural formulas. A molecular formula contains the symbol and the corresponding number of atoms of all the elements in a compound, the actual formula of a molecular compound. An empirical formula reflects only the reduced form of a molecular formula. The subscripts in the original molecular formula are written in their simplest whole number ratio, not necessarily the actual formula. Examples of empirical and molecular formulas of some known compounds are shown in the table. The empirical formula is useful because it can be determined experimentally from the percent composition by mass or from the combustion products. The molecular formula can be found from the empirical formula using the scaling factor if the molar mass of the compound is known. Additionally, a structural formula shows the bond pattern and connectivity of atoms in compound. In a structural formula, an atom is represented by its element symbol, while lines represent single bond and double covalent bonds. Carbon dioxide, for instance, will have a structural formula which looks like O, double bond C, double bond O. Take note that structural formulas are commonly used for organic compounds. Now, can you name some of the most known molecules we use every day? To give some, let us have the following examples of everyday carbon molecules. Ethanol, the C2H5OH, is a type of alcohol found in alcoholic beverages and is also known as ethyl alcohol. An alcohol is a certain type of carbon molecule with one or more hydroxyl, the OH groups. Other common alcohols are isopropanol or isopropyl alcohols, and they are the rubbing alcohol, and methanol or the wood alcohol. Glucose, C6H12O6, is the carbon molecule that is ultimately extracted from food before entering our body's cells. It is a component of sucrose, or table sugar, which consists of one glucose molecule joined to a fructose or the fruit sugar molecule. People with diabetes measure their blood glucose levels regularly with electronic sampling equipment. Macros, the three macronutrients you hear about at the gym. In certain Instagram circles, the carbohydrates or carbs, proteins, and fats all consist mainly of carbon atoms. Protein contains of nitrogen in addition to carbon, hydrogen, and oxygen atoms. To summarize our lesson on atoms, ions, and molecules, let us take a look at the following big ideas. First, an atom consists of electrons that move around the nucleus, where the protons and neutrons are found. Second, the atomic number of an element represents the number of protons in its nucleus. The mass number indicates the total number of protons and neutrons. Third, an ion is formed when an atom loses or gains electron. A cation is a positively charged particle, while an anion is a negatively charged one. Cations and anions can combine to form an ionic compound. A molecule is formed when atoms share electrons, producing a covalent compound. That's it. You just have reached the end of our discussion. Thanks for listening, and I hope you understand our lesson for today. See you on our next topic. Bye-bye!